So we are running what we call an Inno-Swiss project. It's a project financed by the state. We got 850,000 euro. We started 2 years ago, and we still have one year to continue. The goal was to develop technology for the wireless broadcast equipment using 5G. We focus only on the 5G standalone with constant bitrate and single SIM. We don't address the bonding market with multi-SIM cards. The development partner, we have the Polytechnical School in Lausanne, some engineer school, and Nulink is the industrial partner and has all the property right of the project. We have as a use case specification the Swiss television and a department of Swisscom specialized in media production, streaming, and the setup of international contribution line, for example, for Eurovision or for the Swiss TV. They are working for UEFA, FIFA, and stuff like that. So all what I will present now, normally it was planned to present that at IBC last December. Our private network integrate in our 4U rack the core network, the G-Node B. We have 4 interface able to support up to 4 radio head. We are in release 15 for the moment. The setup we planned to use at IBC, we got from the Dutch Ofcom 80 megahertz channel. We set up an upload of 70% in MIMO 1 with 64 QAM. That means around 250 megabit in upload and 150 megabit in download. Why to use only 64 QAM? From our experience, the robustness of the transmission is very critical. In the 5G technology, you can go up to 256 QAM, etc. But it's absolutely not robust enough for the broadcast market. It's what we consider from our experiment. And don't forget that a classic wireless camera most of the time is using 16 QAM and sometimes 64 if it's a short area and you have a good visibility of your equipment. So there is no miracle in terms of bitrate. 5G is not a dream in comparison with what we know with wireless camera using classic WFDM modulation. After, from the base station, we are using SMPTE cable just to benefit from existing cabling in studio, theater, concert hall, etc. To a small box where we have the power to transform the power for the radio head. It's a very clear and simple setup that you can deploy in less than 1 hour on any stadium equipped with SMPTE fiber. For the moment, we are using the NR78 because in Switzerland, we can deploy trials between 3.4 and 3.5 gigs. And for the future, we got normally 100 megahertz of bandwidth in the LTE band 40 to run the business, if you want, with private network for PMSE in Switzerland. First, we address equipment based on NDI. we developed a simple modem just connected to IP to the camera. We are using NDI HX at 18 megabits per second from the camera. And the box, as it's we are using TDD, we are full duplex system so that we can provide return video, intercom, camera control and stuff directly from the same modem to the camera through the IP connection. We also try to integrate the same camera in a kind of studio camera just to demonstrate that we can have return video, teleprompter, intercom system, all integrated in the same network. As long as you have an IP equipment, you can plug in the network and you get the connectivity. For example, if your journalist need to access internet, you just had to connect an RG45 connector cable to the connector on the camera, and he can access directly internet. On a single battery, we have more than 20 hours of running time. For us, it's very important because if you plan to produce wirelessly, you need also to be as much possible independent from the power. Another kind for PTZ camera, through the same connection, you have the PTZ controlled by the joystick from the control room. We also are testing our network with HEVC product. We have our ultra low latency product line, encoder and decoder, where we encode and decode in 20 milliseconds with this equipment. And we have worked to provide IP connection on the encoder and on the decoder that we can adapt our 5G modem in IP on our external HEVC codec if it's not an NDI solution. This solution is more to address the high-end market when you have to mix wire and wireless camera of a higher quality level than NDI, if you want. We also have an integration in collaboration with Brass Valley, in addition to the collaboration we have with Panasonic. Regarding distribution of video, the same modem can broadcast video. Depending if your setup is HEVC or NDI, we just have to implement the right decoder in our modem. Regarding the audio, we have the same modem if you want. If you can do video, you can also do audio. In this case, we are using uncompressed audio. For example, you can have this box at the belt of a journalist. You have all the feature you need. You can also get the video return if the journalist needs a small monitor, for example. You can manage the N-1 or re-eject its own voice in the headset, for example, on a starting grid of a Formula 1 Grand Prix, without to go to pass through the control room. As it's IP, we can, for example, control the gain and adjustment of the audio directly from the OB-WAN or the control room. Same for audio distribution. You can have audio only or also different TV monitor that you can connect on the same modem. In terms of deployment, in NDI, it's quite easy. Just behind your private network, you have a switch. We are using TreeCaster behind. We just connect the TreeCaster to the switch. we have a PC running as audio server to control the distribution, acquisition, and distribution of the audio. We have integrated RCP from SunView, and it's worked perfectly. As long as you have an IP equipment, for the moment we have not faced some big issue. With NDI, in terms of latency, one way 250 milliseconds in HX. We add 10 to 15 milliseconds. It's not really stable from the private network. It's clear that URLLC will help to reduce the end-to-end latency. Synchronization is integrated in NDI, so we don't take care of that. So total for one way, it's between 260, 265 milliseconds, which we consider that it's a limit to operate PTZ joystick for the PTZ camera. But it's workable, but it's really the limit. So for the return video, you have two ways, so you double the time, plus the latency depending on which kind of decoder, NDI or HEVC or any kind of other decoder. The implementation will also add some additional latency. If you are in the HEVC mode, you have just to add some HEVC decoder behind the IP switch. That means you give to your decoder all your IP stream coming from the network, and after you recover your 3G SDI signal to go to a standard mixer, going through frame store synchronization in this case, because nobody is taking care of the synchronization in this case. So regarding the latency, we have 20 milliseconds end-to-end plus the network. Synchronization 20 milliseconds through the frame store synchronizer. What we call network stability buffer, it's very difficult without this buffer to have a 100% stability of the decoding that comes from the IP world. So we have a total of 70 milliseconds for the moment in one way. That means 140 both way, plus again the decoder implementation. Regarding the synchronization, maybe one of our idea will be to try to genlock with the PTP the base station, and to use the TDD back channel to the camera to try to synchronize the camera to avoid the frame store synchronizer and to save 20 milliseconds. Other service that we have integrated in the network, we have integrated Unity. We just installed the mini server behind the private network, and we success to deal with Oppo. Maybe it is the Unix 3 smartphone in Switzerland working in 5G standalone. It was very difficult to get this kind of equipment because Apple, Samsung, all the other ones, when you ask for equipment in 5G standalone, they said no, it's not activated, you cannot have that, we are waiting for the public network. So with Oppo, we success to get that, and it's perfectly just, we program the SIM, we put in the smartphone, and we have the full intercom system in the same network. If your base station has an IP connection to the world, well, you have the prolongation of your intercom worldwide. In collaboration with Swiss Timing, we have worked on a commentary position 5G that we have. The tower is our modem, integrating a switch to connect different kind of equipment, to have the return video, to connect the audio from the the console in IP, and to connect the computer to access the competition information system from Swiss timing, to pick up from the cloud all the information, the commentary position needs to comment the sport. For this solution, we would like as soon as possible to start to make some testing in the millimeter wave, because it's a classic fixed access setup, because you can have the antenna on the roof just 30 or 40 meters up of the commentary position. Nobody is moving, so that could be perfect for a millimeter wave setup. Unfortunately, for the moment, it's difficult to find the radio head and the SDR board to go with this trials. But we are in discussion with UEFA and through Swisscom. They are really interested by this kind of solution. If they can set up in 2 hours 40 position for a Champions League match instead of spending 2 days of cabling, they will be very happy. We also developed a small modem for the press, for the still camera. For the Olympics, the next Olympics, the new still camera will have 45 megapixel. So that means in RAW, that will be very huge bitrate to transfer, especially if they take a 10 or 20 picture in Rafale. They would like to have that in 2 seconds on the cloud. So maybe Wi-Fi will not be the valid option for that. But maybe, again, 5G millimeter wave could be a good solution with, I don't know, 3, 4, 5 radio head installed in the stadium. Basic deployment at venue. Well, if you are in a classic setup with the control room or B-van or container on site, it's very easy. You have your private network in the OB-van, SMPTE cable to the stadium. We can add up to 3 more radio head if you need to cover different other area, like the bus arrival or the tunnel mousse or changing room or stuff like that. If you want to work in remote production, we tested with Swisscom over dark fiber, just to have an IP dark fiber between the private network and a centralized production room. It's worked perfectly. Now we plan to test with NDI5 with bridge to check what is how the system react on public internet. If we can, if that could be a solution or not. For cloud production, we don't expect any problem to use this kind of setup. The unique problem is how to maintain ultra low latency in the cloud. As you know, in MPEG 5 at HEVC, the lowest latency is 120 milliseconds in the main profile standardized. At the moment you want to reduce the latency, you go out of the standardization. It's what we are doing. We encode in slice, etc. But at this moment, you are no more compatible with any kind of decoder, software, VLC, or stuff like that in the cloud. And after, the solution become too expensive because they have to dedicate special resources for you, maybe hardware or stuff like that. So maybe the solution could be an hybrid solution where you keep on the stadium side the shading and maybe some critical operation with the joystick and stuff like that before to go to the cloud. And after on the cloud, the latency becomes less critical just for the director to produce the program.
Thanks, Laurent.
Just the next step, two slides. That's the example from Paris regarding the spectrum in different band, and we match with the 5G official standardized frequency band. As you can see, there is a lot of spectrum available for PMSE, but not addressed by 3GPP. So for us, it's very critical in the sense that it's not true to say that there is no spectrum for PMS, for private network for PMS. But if the broadcast industry wants to extend the use of private network, we need to find a solution or to motivate the chipset manufacturer to provide a chipset covering more than the 3GPP spectrum. It's not the problem of the radio head, not the problem of the base station. The problem is on the chipset you have in the smartphone or in the data card you use to build a 5G modem. So just the next step for us now, it's intensive field trials with different partners, and in Switzerland, the Swiss TV, etc. We started to develop our own 5G private network. Today we are using some external part, but as it's a server-based, there is no big difficulties to develop our own private network. And we will start the development of our second generation of ultra-low latency HEVC, maybe with 12 gig input, SMP PTE 2110, what kind of synchronization mechanism we can put, and to industrialize our product line. And we are open to any new partner in the project. We are searching, like everybody, for financing, for a distribution partner, for industrial partner. You know, we are on a research and development project. It's not an industrial project. We don't plan to sell ourselves something. So if somebody is interested, please contact us.